Hello everyone, welcome to Tririte, the new era of learning. This is Pack 365. In Module 2, uh, we discussed Astor algorithm in AI in previous lecture. So this is part C in practical way. We discuss Astor algorithm in theoretical way and we explain the behavior of the theoretical way. Now it's time to learn in practical way. Okay, so let's start the topic. So we all know that we also see this starting how the initializing state was taught and removing the steps we will discuss in previous lecture. And this is the graph we which we exploring now. So we start from as we choose the lowest path from A to so A B to in A B C we choose the lowest path as A we connect with A and in that we explore B and C sorry B and D in that we use the lowest path as D we choose D and after the in D we explore the H I F in that we choose as the lowest path to explore as F in F we reach our goal state after that also does not stop our exploring the path. We used to find all the nodes, right? So for that also, the algorithm still continues to be and see at exploring all the paths, and it gets the final value here, right? So we reach our goal state. So in practical way, we reach now the goal state. So let's go into the code. So we are create a variable of star.py. Create a variable. So what we are doing here? So first we want to doing a co here, right? First we can write the comments what we are doing here, right? So first we want to write the steps, right? So for that we take I take a comment loop here. I will write here steps. So here I writing the A star search here. A star search algorithm in some implementation, right? I'm using a graph, right? The graph to search start and goal and yeah, heuristic value here. And after that, I want to start from heap mean value to find out that piece. So let us start. I will take a comment. Instead of comment, I will take. Wait a second. Yeah, it's fine. So I'm start from here. So first for that, I was to import from heap method, heap push and heap pop, heap pq. From heap pq, I will import the heap pop and heap push. Okay. So from this, I create a function called a star search. So here I consider here graph. Here a p है graph and in graph I'm consisting dished direction. So after that I take start here, start from str and my goal is to reach from str start to heuristic value, right? In now here I'm exploring the now here I want to explore here. So we take here a min heap is you good to implement the purity query, right, for the open list, and that and we can consider here the heap we consider the heap quiz like PQ module for the from Python from standard library to utilize, right? So entire in the heap or tuples of the form, cost and node, and ensuring the entirety of nodes entry with the lowest cost is always smaller during the compression. And here we can consider that the heapiest operation is not required as the heap module maintain the heap what we can say invariant, right? Invariance after every push and pop operation. So here we can consider that the closest list is to implement has a set of efficiency relationship. We want to check in it. So for that, I want to creating we have the two listed open list and closed listed. So I want to create a open list and closed list. So for that, I want to consider a loop and do loop. I want to iterate that open list. So first we create a variable has open list, and I created closed list to that. Um, Considering a list in that I using a heuristic value heuristic values and then a start, and after also I'm selecting start because I'm start heuristic start and this is a main start, right? So then I want to set it. So here I'm running a loop while open list. While open list I'm running a cost here and node cost and node. I'm creating a variable cost and node. So to that I am using heap pop for open list. If you consider it, pop the heap. So you're considering the algorithm ends when the goal has no explored bin, right? So goal node has been explored. When it explored, we want to check not when it is added to the open list. So we want to check it if the goal state is okay, it will return. So how we check like if node equal to goal, right? Goal state. So we can return here cost. Okay. So if it is if node in closest to list, we continue it. Okay, if a node in closest to list, we continue it. So here the closest to list will be add into node. Okay, so now it also done. So here what I want to do, I want to extract like subtract the heuristic values and has it over counter, right? So for this I am taking the cost. I am taking consider here cost here, and here what can here I am considering cost and okay, it's something network issue. Okay. So cost equal here, and we use the heuristic value. So we consider in it as node. Okay. So from here, I want to check the edge neighbors and edges, right? So I'm taking the neighbor to check whether for neighbor column A edges, edge cost in graph node. So some functions may be already predefined in it in the heap in this module of heap PQ. So it doesn't treat like we doesn't create any neighbor variable here, edge cost variable here. So some variables is predefined in it. So we want to just use on the time. So if neighbor in closure list, we will be continue here. And the final, we want to check that f of x equal to g of x plus h of x, where g of x is a path of cost and h of x is a heuristic, right? So we want to check it, right? So for that, I'm taking again neighbor here. I'm getting a variable called neighbor cost. In that I'm calculating the actual cost plus h cost, right? H cost plus heuristic loss. So here we calculating the starting stage of cost. Here we calculating the H cost of actual cost of g of x. Here we calculating the heuristic cost, right? Heuristic value of neighbor. So here I'm using heap push for open list into neighbor. Neighbor cost and its neighbors. Right, here the till which the code is clear for you. So now the main task is here. We come here and we push the heap here and push the node. So the main task is here. We want to return the statement and we want to create the those lift of S to G. We want to create up to we have A B C D E F G H I J K L M N up to K, right? So till that we want to create a function. So I will return on it return -1 if hashtag no path found. Okay. So here we can and start the example. So we can start our ex- example graph here by considering a in this a dictionary. So a using dictionary statement further s equal to somewhere assigning the values to the this here what we have a comma 4, right? Values and we want to add in this in this brackets we want to add the actual value and estimated value and the parameter value, all those values we calculated, right? So I want to add those all values in this list. So I'm gonna have b here. So in b I have 10, and in c, don't worry guys, I'm entering the right value because I have a diagram of graph my beside. So we are calculating. So just instead of like this, we're taking a lot of time, right? So let us make quicker and easy. Like I consider all those values here. So I want to take A, here I want to take B, here I want to take C, here C, T, right? E, F, H, I, and here J, and I want one another final here, right? With point here K. So I want to only change the values here. So A10, B10, right? So here B, right? I moved here B. In B, the value is 8. Now I move next to the D. In D, the value is 5 here. So I don't want to this extra consider here. So here also I declared up to this value. Just my value is here. For B, we travel D, right? D value is 15. And here for D, we travel here again from 8. And for the travel E, right? In E, we take 20. In F, we consider. So, okay. Here also, in again, we travel from F. In F, we take 1. In I, we consider here 20. H, so we take 16. So, it's fine. So, till that, I want to remove this 2. So, we take 13, right? 13 for which we are considered F2. E2, G, F2. So, wait, here, we did a mistake. A, B, C, D, E, O. It didn't take any row called E. So, sorry, guys, it's my mistake. Okay, now we travel D to F, D to E to G, right? G is 19. Yes, the value is correct for H. And here 13 for again G. Here the H, for H we travel to the J, right? And for J we consider 2 here. And for B we consider here I, here we will to travel I, right? I is with 1. And then from I we can go for K. In K it is 13, right? No, we see the value of G, which you have value of 5. And what is the J heuristic value of J is what? So we consider again J. From J we take 7. And again here we take G. We find the final weight. In this we consider 16. So overall this finishes. So again, we want to enter here another like nodes. Here we want to enter the nodes of heuristic value. Here we entered only g of x values of those which we traveled. Like we go to S, have we in first stage we have A, B, C. In second stage we will explore the B, D. In third stage we directly D. In D we have like that we explore the step by step. So like that here also we create the example of heuristic values here. Heuristic values. We also will calculate some values and we are going to initiate the number of 7. Okay. Put in the we are entering 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So here number is we start from S, A, B, here right, here B, B, D, E, here G, H, I, J, and finally we go to K here. K. So numbers where we can take has 8 here and 6 here and 5 5 here, again 5 here, again 3, again 3, 0. In H it is 7. Mm, in I it's 4, 5, 3. Right. We consider the values of here. Check A, B, C, D, E, F, G, H, I, J, K. Okay, now we want to explain the we want to explore those nodes. So we take example graph, example equal to A star, right? We consider A star such, and here in that example graph, like we consider it here, in the result we are considering example result we take as a variable as example result equal to A star of example graph here. In this we starting is yes, and our goal is G. So we want to enter the capital G because we instant variable is also yes and G. Then we can consider the example heuristic value here. So done. So print example value. Print example result. So now we can see here we can run the code. So we want to get the 23 as a output. Wait a second. Key error. Graph node key error. S is key error. We get graph node and the node from the node edge. Wait a second. We did any mistake it here. It's right. Edge posting. Wait a second. I'm checking the error. So I got the error. Just it is a spacing mistake. Okay. So I got the output as 23. So we process those static these were ABC in graph patterns. So here we did the output as 24 because here also we get the output as 24 only, right? So the final output is 23 from reaching H to G, right? So we can see the G is we can see the G is 23. Here we can see the G is 23. So our goal is 23. So obviously we reach out to goal 23. So I hope you guys all are understand about this topic. Thank you.